Okay, welcome to the video for 2.3 quantities of molecules and ions. So this is the last subtopic for topics 2, types of materials. In this video, we'll be talking about the percentage composition of elements in compounds that can be determined from the molar mass of the atoms. What you need to be able to do is to undertake calculations of percentage composition by mass of elements in compounds. We'll actually do that later, and before that we'll look at the number of moles of particles in molecules or ions in a sample can be determined from the mass of the sample and the molar masses of the particles. You need to be able to undertake calculations using the relationship n equals to lowercase m over capital M. Smaller case m is mass and the capital M is molar mass. So I actually prefer using n equals to m over mm, double capital M for molar mass. And also its rearrangement for molecules and for ions and their compounds. All right, let's look at the relationship here. Okay, so the number of moles of particles, whether it's molecules or ions, in the sample can be determined using the relationship. As I mentioned already, I personally prefer writing mm, so double capital M for molar mass. N means number of moles in moles, sorry, MOL, mole, and also masses of the sample is written as M, and it should be in grams, not in milligrams, not in kilograms. M or mm, capital M or double capital M, molar mass of the particles would be in grams per mole. Grams per mole. You can write it as G/MOL or how it's written on there. Let's say G mole with -1. Okay, let's look at the example which is on the board. But the question is, a 1 kilogram pack of bacon contains 10.0 milligrams of nitrate ion as preservatives. Now, if you don't know what the nitrate ion's formula is, you better know that because that was part of 2.2. Okay, you need to learn how to write polyatomic ions off by heart, top of your head. All right, so first question, find the molar mass of nitrate ion. 2. Determine the number of moles of nitrate ion present in a packet of bacon. 3. Find the number of ions, number of ions of nitrate ion, which is capital N, present in a pack of bacon using Na, which is Avogadro's number, 6.02 times by 10 to the power of -23. Okay. All right, so in the first question, you need to, again, know how to write formula for nitrate. NO3 minus it is. NO3 minus is nitrate. In nitrate, if you look at the formula, there's 1 N and 3 oxygen atoms. Forget about the charge. Even though it's got extra charge, it doesn't really add to the mass. So look at the atoms. 14.01 is the mass for molar mass for nitrogen, and oxygen has 16.00, and there are 3 of them. If you just add them up, you should get 62.01. Unit is in grams per mole. Make sure you add the unit. So that's the answer for the first question. Second question, you are finding number of moles of nitrate ion, and you can find that if you divide the mass of nitrate ion in grams by molar mass. You can use double M here, double capital M of nitrate ion, which is in grams per mole. Now, question is telling you to use 10 milligrams. 10.0 milligrams, which is not the right unit. So you have to firstly convert that into grams. So 10.0 times by 10 to the power of -3. That makes milligrams into grams. Divide by what you have calculated before. So 62.01 grams per mole. if you do the calculation, you get 1.1626 times by 10 to the power of negative 4. Now, here's a question. Where do you cut off the number? Now, in chemistry, you look at the numbers which were used in the calculation, and in this case, 62.1 and 2 digits are the smallest number compared to, you have to count 1, 0 as well here, so 3 significant figures. 2 to 3, which is smaller, you pick 2. So 2 significant figures need to be given, so 6 here need to be either chopped off or rounded up. 6 is above 5, so more than halfway, so you get 2 here. So in 2 significant figures, 1.2 times by 10 to the power of negative 4 mole is the answer. Moving on to the third one, you are asked to find number of moles, number of ions in this bacon package. So how many moles were there? So how many number was there? You can find out by multiplying number of moles, which you found before, times by Avogadro's number. I just had this number in my calculator screen, so I just use that and then multiply 6.02 times by 10 to the power of 23. And I got this number. Again, in 2 significant figures, 9.7 times by 10 to the power of 19. In this case, unit is just ions, how many ions there were. So yeah, that's the answer. So that's the example of questions that you might get. All right. Now let's look at percentage by mass. So the percentage composition of element in compounds can be determined from the molar masses of the atoms using this relationship. Percentage of element in compound equals to molar mass of element, molar mass of element times by number of atoms of the element over molar mass of compound times by 100. So you can get the percentage. The arranged formula would allow you to find, firstly, mass in grams of an element when ratio of element and also percentage of elements are given. So you could get a question like that. Find a mass of element from this ratio of elements and also percentage of element in this compound. Or you might ask to find even a formula of a compound. And also number of atoms of an element when mass of element and percentage of elements are given, vice versa. Make sure you can rearrange this formula and use it with any number. Okay, example. Which fertilizer contains the most amount of nitrogen by mass? Now, nitrogen is very important for plants to absorb. It needs to be water-soluble form, otherwise it doesn't get sucked up with water. All right, so type of nitrogen fertilizer, we've got urea, ammonium sulfate, as well as ammonium nitrate. Now, they have got different chemical formula as well as molar mass, which are given. Now, from here, I want you to be able to find percentage of nitrogen per mass, by mass. You do that by using the formula that was given to you just then. So the percentage by mass of nitrogen in each of the fertilizer is determined as follows. I'll zoom that in for you there. Okay, so in urea, so what you'd have to do is to do molar mass of nitrogen times by a number of atoms of nitrogen involved over molar mass of the whole compound of urea times by 100. So you would do 14.01, so nitrogen mass, times by 2 atoms involved over 16.062, which is the molar mass of urea, times 100, then you would get 46.65%. In ammonium sulfate, do the same thing, but you just have to change the number of things. In this case, you still have 14.01 as nitrogen's molar mass, and number of nitrogen involved is still 2. So only thing you have to change is the molar mass of the compound. So ammonium sulfate has 132.144, so use that. And if you calculate it, you get 21.20%. And similarly for the third one, you get 35%. So looking at that, which nitrogen fertilizer had the most amount of nitrogen by mass? Well, it's urea. So in this case, if you were to apply this to a context, you might say urea is the best choice and that should be used. All right. Few terminologies that you would see in this part of the questions. One is molecular formula and the other one is empirical formula. They are similar. They are both types of formula, but they are different as well. Molecular formula is a term used to say that the exact number of type of each element are shown in the formula. Whereas in empirical formula, simplest whole number of ratio of elements are just shown. For example, molecular formula of glucose would be C6H12O6, 612,6. If you write that in an empirical formula, you'd be writing the simplest formula. So you can divide all 6, 12, and 6 by 6, can't you? So you would get the simplest formula as 1, 2, 1. So CH2O would be the empirical formula for glucose molecule. All right, I hope you got that. And we can do some questions and prepare yourself for doing those end of topic test now. That's it. That's it for unit 2. All right, I'll see you in topic 3 videos.